We're going to move from simplifying singular rational expressions to multiplying and dividing rational expressions and then simplifying the final solution. You'll notice that in this example, it's somewhat similar to some things we've done before. We have two fractions being multiplied together, and it's already in factored form. We have common bases and exponents that we're multiplying and dividing, so we have to use those appropriate rules. First thing I notice is I have a 7 and a 49, and 7 over 49 reduced to 1 time and 7 times, so I'm going to put a 7 down in the denominator of the second term. I notice I have an x squared and an x to the first. Common bases, therefore I subtract two exponents and keep the answer where the greatest exponent is. So I have an x in the numerator. Next I have a y and a y to the fourth. I'm going to once again subtract the two exponents, so it's a 1 and a 4, get a y cubed, and that's going to be in the denominator because the biggest power is in the denominator. Notice I have a z cubed and a z. Biggest term is in the denominator, subtract the exponents, so that's z squared. And that takes care of those. And then the only thing I have left is the 12 and the 14. And those reduce. 2 goes into both, 6 times here, 7 times here. And now I can take a look at this and reduce anything that's left. I see the two 7s reduce out. And left with x over 6y cubed z squared. And that's my simplified product. Now we move into more complicated terms where it's going to take factoring in order to reduce. Remember, once again, we can only reduce multiples or divisions of factors that are exactly alike. We may never reduce across an addition or a subtraction. So in this first term, you'll notice the numerator is already in factored form. The denominator has a GCF of 4, leaving you with b minus 3. That's multiplied by, I'll factor the numerator. You need to find out what multiplies to 3 and adds to negative 4. That's a b and a b, and a negative 3 and a negative 1. In the denominator, I have b and a b. What multiplies to negative 30 and adds to 7. That's a 3 and a 10. Negative and positive. And now I can reduce anything on the numerator that's the same as in the denominator. So you'll see I have a b plus 3 that reduces, b minus 3 that reduces, and then that's all I have that's in common. So my final solution is b minus 1 over the quantity of 4 times b minus 10. And I can leave all those solutions in factored form. Here's another example using some of the factoring techniques that we've already talked about. In the numerator, I need to find two things that multiply to 9 and add to 6, and that's a plus 3 and a plus 3. Denominator, what two things multiply to 25 and add to negative 10? That's an a minus 5 and an a minus 5. Next term, what two things multiply to negative 20, add to negative 1? That's a 5 and a 4. 5 being negative, 4 being positive. And then finally, what two things multiply to 12, add to 7? That's going to be a 4 and a 3, both being positive in that case. Look for the terms that exactly match, both in the numerator and the denominator. The a plus 4's reduce, a minus 5's reduce, one of the a plus 3's reduce, leaving me only with a plus 3 over a minus 5. In this next example, the factoring is going to get a little bit tougher.
the numerator on the upper left, we'll have to use a 5-step method, so let's go ahead and do that. I've got a squared plus 9a plus 18, and we find what multiplies to 18, adds to 9, that's an a plus a 6, a plus 3. Remember it's a 5-step, so I divide by 2, and we get a plus 3, and that doesn't reduce, so I bring that forward. That's a 2a plus 3. Now I'll do this next term. We've got a squared plus 19a plus, what is that, 42. And what multiplies to 42? So this guy right here is a negative. What multiplies to 42 and adds to 19, that's going to be a 21 and a 2. Positive 21 and a negative 2. Divide by 3 in both cases. And I get 3a minus 2 and a plus 7. Next term, these are perfect squares, so that's just a plus 7 times a plus 7. And then the last term, I prefer to rearrange that so my a squared term is first. So it's a squared minus 6a plus 9, which is, again, perfect squares. It's a minus 3 times a minus 3. And now rearrange this all so we have a multiplication problem back. I have a plus 3 multiplied by 2a plus 3 over 3a minus 2. Let's fix that. So over 3a minus 2 times a plus 7. It's going to be multiplied by this next fraction of a plus 7 times a plus 7 over a minus 3 times a minus 3. And now we look for terms that are exactly alike. We'll reduce those. So here's an a plus 7 that goes. I don't have any a plus 3s. I think that's going to be about it. So in this case, I can just say I've got 2a plus 3, a plus 7, and an a plus 3 over 3a minus 2, a minus 3 times a minus 3. Didn't clean up very nice, but cleaned up a little bit. Alright, so we've got a little word problem here. Velocity of a spacecraft must have to escape the gravitational pull of the Earth is called the escape velocity. And the escape velocity for a spacecraft leaving the Earth is about 40,320 kilometers for 1 hour. And we want to write this in terms of meters per second. So what I'm going to need to do is do some dimensional analysis. This is a little review. So in this case, I need to know how many meters are in a kilometer. Well, there's 1,000 meters in 1 kilometer. And then I need to know how many seconds are in an hour. And then I have 1 hour, 60 minutes. And then in 1 minute, there's 60 seconds. So you'll notice now I get to reduce kilometers with kilometers, hours with hours, minutes with minutes, and I end up with units of meters per second.
I'm going to multiply the numerator and divide that by the denominator and end up with my meters per second unit. And I end up with the following, roughly 11,200 meters per second. And that's my escape velocity. Now we're going to divide these terms. Dividing rational expressions is the same as dividing fractions. I want to multiply by the reciprocal. So in this case, I have 8 over 20x cubed multiplied by 25x squared over 44. I'm going to take and reduce where I can. So the 8 and the 44, there's a 4 that goes into both. 2 times here, 11 times here. 20 and the 25, 5 goes into 4 times and 5 times. And then we've got this x cubed and x squared. Got a 2 and then a 5. The x and the x squared, bigger terms in the denominator, subtract the powers, that's an x, and I have a 4 and an 11 left. So I'm going to multiply what's left. It leaves me with 10 over 44x. 10 and 44 reduce because 2 goes into both. 5 times in the numerator, 22 times in the denominator, and the x is left over. So that's my reduced solution. Factoring is going to come back into play. We'll take and rewrite while we factor. So this denominator here goes to x minus 6, x minus 3. Going to multiply by the reciprocal, so I put an x minus 6 in the numerator. Denominator factors into x plus 5, x minus 5 because that's a difference of squares. Now I can multiply, reduce any term that's exactly, or any factor that's exactly alike in the numerator and denominator. So I go ahead and do that. You'll notice everything in the numerator is reduced. That doesn't make the numerator equal to 0. Anything over itself reduces to 1. So I have a 1 in the numerator over x minus 3 times x plus 5. And there we have it. Here we go again. Very similar example. We have some greatest common factors in this case. The numerator has a 6, leaving me with a plus 1 over a minus 1. Going to multiply by the reciprocal. I have a 2 as my GCF. A minus 1. Denominator factors into a plus 2 and a plus 1. I reduce like factors once again. The a plus 1's reduce. A minus 1's reduce. In the numerator, I'm left with a 2 times 6, which is 12. And in the denominator, I'm left with an a plus 2. Again, the factoring will get a little more difficult. Let's take and do a 5-step to the numerator. I have a squared minus a minus 30, which factors into a minus 6 and a plus 5. Divide through by the initial multiple of 2, giving me an a minus 3 and a 2a plus 5. It's going to be over a minus 3 and a plus 1. Now, in the second term, I'm going to take and find the reciprocal, so I'll start with an a, or 1 minus a squared. And remember, I'm not a big fan of factoring with a negative squared term, so I'm going to factor out a negative 1, leaving me with a squared minus 1. And there's a difference of squareds there. So I have an a plus 1 and an a minus 1. And then in the denominator now, I'll do a 5-step of a squared plus 3a
minus 10 gives me an a plus 5, a minus 2, divided by the initial multiple, giving me 2a plus 5 and a minus 1. Again, I'll rewrite this problem in factored form. So I have an a minus 3 multiplied by 2a plus 5 over a minus 3 times a plus 1 multiplied by a negative a plus 1 times a minus 1 over 2a plus 5 and an a minus 1. Like factors reduce, a minus 1's go, a plus 1's go, 2a plus 5 goes, a minus 3 goes. Looks like everything went except this negative 1 here, so my final solution is negative 1. That's all we've got for you. Answer the questions and write your lesson summary, and we'll talk to you tomorrow.